Okay, so this lesson's being recorded. Obviously, make sure you mute the microphone, use the correct language, and just use the chat when directed to and to ask questions. So it's being recorded, and we'll be back here at 10 to 11 next week. So reminding one is here. So on our plan for our lesson, so we're on week 2 coastal landscape. So of course we're building up to that week 5 exam. So we will be doing an exam, a paper section from Edexcel you're looking at, and obviously that will help us with your predicted grades should anything happen again, as it could. So let's crack on with what we need to do today. So you should all have your sheets in front of you or on your screen or printed out, or you can be doing it on paper if you want to. So we're going to start off by looking at waves. So we're going to be looking at the formation of waves and the impact of them. So the key thing about waves, of course, is the energy that they're getting from the fetch. So the fetch is the distance the wind blows over the sea, and the longer that fetch and the stronger the winds, the more powerful, more energy those waves have. So as you can see, we've got that map on the slide there showing us the UK, and we can see the prevailing winds coming in for us from the southwest. So that means the winds are being blown all the way across the Atlantic Ocean, all the way across from South America, thousands of kilometers. So those waves are massive with huge amounts of energy when they get to the southwest, which of course causes a problem with erosion, but also creates some great waves for surfing. So that's why it's so popular down there. Another key thing, of course, that we need to remember is what the waves do. So swash and backwash. Swash when the wave goes up the beach, backwash when the wave comes back down the beach. And remembering the wave always comes directly back into the sea at right angles to the beach. Gravity is pulling it back down. Remember I've said to you before about your way of remembering this is about if you're drinking from a bottle. So, and particularly if you share that bottle with someone else. So when you drink from the bottle, that's the swash. And then obviously when you sort of finish with your bottle, there's a little bit of backwash from your mouth back into the bowl. So if you share your water bottle with someone else, you're also sharing with them loads of phlegm. So swash and backwash, always at 90 degrees. So let's have a look, and you can see at the top of your sheet, we're not actually going to do a diagram, we're going to actually write something in there, give you an activity. We're going to look at the 2 distinct types of waves, constructive and destructive waves. So we can see here, we've got constructive waves, a strong swash, lots of energy going up the beach, very little energy coming down the beach. So the deposition is greater than erosion. They add material to the beach. You don't need to be writing this bit down at the moment. Destructive waves, you can see, have a weak swash and a strong backwash. They create erosion. They destroy the beach. They remove the material. Okay. So from what we have talked about there, what I would like you to do is to sort these statements and write them into your table. So you've got to sort these statements and write them under whether they are constructive or destructive. So I'm going to give you 3 minutes to complete that task. Go. Okay, so let's just check. I'm going to put the answers up on the screen for you. So here we go. So constructive waves, weak backwash. They do have a strong swash. They take the material up the beach, but they do not remove it. So they build up the beach, they make it bigger, they construct it. The waves are only up to about 1 meter high, so they're quite low in height and low energy. And you only get 6 to 8 per minute. So not many waves per minute. Destructive, weak swash, more energy. So they remove material from the beach. So they don't take it up, they drag that material back down the beach. They break very frequently, so you get 11 to 15 per minute, and they have that strong backwash where they're removing material from the beach. I have put a copy of this PowerPoint into the files section of this team, and of course there will be a recording. So if there's anything you will need to go back over and look at, we'll be able to do that. It's anything you need to get copied down. So let's talk about our processes. And of course, last week we talked about processes, and I hammer into you all the time, bang on all the time about processes. So those 5 key processes. So we're going to concentrate on a few of those today. So you've now got underneath, you've got a table and a space for an explanation and a diagram. So you've obviously got a space where you can be writing something down. And obviously we've got to illustrate those with our favorite animations, Disney, eat your hearts out. So you need to be putting down in the explanation, and then you can draw your own little diagram in the box. So you can see hydraulic action. When waves crash against the cliff, impact, force and weight of the water wears the rocks away. Let's watch the video. Hopefully it will play for you all.
Hydraulic power.
Fantastic. So you need to be putting down your explanation for hydraulic action and a short little diagram. Now remember, there is that secondary point that we've got where it is the force of water hitting the cliffs, but also you do have that extra point where it compresses the air that's found in the cracks of the rocks, the faults of the rocks. So when the wave comes crashing in, it compresses the air that's already in the cracks. As the wave comes back out, that air expands and explodes. Now, not a very big explosion, a tiny little explosion of an air, like if you squeeze a bit of bubble wrap, but that constantly repeated action of those small little explosions will weaken the rock, and they will also make it fall apart. So hydraulic action, the force of the waves crashing against the cliff. So the bit I put in red, of course, is your key information. You can add the other bits if you want to. But the energy, the waves crashing against the cliff, wearing the rocks away. Okay, let's go on to abrasion. Let's watch the video.
Hey, stop abrasioning me.
Well, quite right too. So, abrasion. This happens when fragments of rock and pebbles and sand are picked up by the waves and thrown against the cliff face. This causes pieces to break off. So rather than just being the water, this time we've got water and rocks or pebbles or sand within it as well. So the force of those pebbles or rocks and sands crashing it into our cliff face starts to wear it away. So thinking about your diagram, you could show rocks hitting a cliff and bits breaking off. So it's all about the water with rocks and stones and pebbles in being thrown at the cliff face and then breaking off and it being worn away. Just give you a moment to get the abrasion sentences down. Okay, solution. What's the video? Rock. Chemically, the rock has got smaller. It's a chemical action on rocks by the seawater. So seawater is naturally acidic. Obviously, as we talked about last week, there are also pollution is adding to that acidity. Particularly rocks such as limestone are affected by this type of solution erosion. So our rocks are being dissolved by chemicals. So in your explanation, this is a chemical action on rocks by seawater. So rocks like limestone are particularly affected. And finally, attrition.
I found a rock. I still got the rock. Ow.
So attrition, rocks hitting each other, rocks smashing into each other, and when the rocks hit each other, they break up and they become smaller. So the more times these rocks hit each other, the smaller they will become. And that's why we eventually end up with sand on our beaches, which would have started off with much larger material. So these are rocks colliding and fragments coming off, and the rocks getting smaller. So that's what we've got going on here. So rocks colliding, fragments coming off, and the rocks getting smaller. So eventually we do end up with those little tiny sand particles left behind at the end of it all. So we've got our 4 types of erosion, and we know we always refer to the type of erosion. We don't just say erosion, we always refer to the type of erosion that is taking place. Very important that we do that. So you should have had a moment to jot down the definition, and again you can do your little diagram there as well. So we need to move on. And we're going to move on to transportation, coastal transportation. How is this material that's been eroded, how is it moved? So there are 4 main types of sediment or rock transportation can be identified. That's what we're going to look at. So we're going to look at how rock can be transported. So to start with, we've got traction. Don't worry too much. I can give you a thing to add. I'm going to give you another diagram to write things down here. I'm just going to talk through them. So traction, this is where large pebbles are rolled along the seabed or large rocks. Like that one. So large rocks are rolled along the seabed. This requires the most amount of energy to take place. Flotation, hopping, skipping, bouncing rocks. They're too heavy to be carried by the water, but they're light enough to be picked up by the water. So we get rocks bouncing and skipping along the coastal river seabed. Suspension. So these are the particles of rock carried, suspended by the water. There they go. All those rocks being suspended by the water. And finally, solution. This is where rocks have been dissolved into the water. So rocks such as chalk and limestone have been dissolved into the water, and they get carried along by the water, just like the rocks there. Could you now add these labels to your diagram? I will just give you 2 minutes to get that done. Okay, so let's crack on. We move on to our headlands and bays. Of course, I'm including this stuff because you will need to know this for your exam you've got coming in a couple of weeks. So we're going to look at what are called discordant and concordant coastlines. These, again, you have all got target grades that are higher, so this is a term you need to know. So a discordant coastline is one where you have got rocks running at right angles to the coastline. Now, this is important because you may well get a question in the exam that will ask you for a feature formed at a discordant coastline. So you should already be starting to see, you can see the labels on this diagram, what's there. So a discordant coastline, rocks are running at right angles to the coastline. A concordant coastline we can see down here. So concordant, the rocks are running parallel to the coastline. So you will have a layer of rock facing the sea and then another layer of rock inland going in and going in. So what we're particularly interested in are discordant coastlines. And we're going to see about the formation of features on a discordant coastline. Now, of course, the key thing there is about headlands and bays. So you may well get an exam question that asks you for a feature formed on a discordant coastline. Now, again, as I've talked to you a lot about, we are always after picking up those marks other people aren't going to get. Because if other people don't know what discordant means, they're not going to be able to answer the question, even if they know what headlands and bays are. So discordant coastline, the rocks are at right angles to the coastline, and of course that means we can get headlands and bays. So you've got a little space to draw a diagram. You can do a simplified version of this. You can write it out as sentences, however you'd like to do it. But obviously what you can see is they've got these bands of rock that are at right angles to the coast. So in this case, we've got clay at the top, then harder sandstone, then the softer clay, then the harder chalk and limestone, then the softer clay. So the waves are coming in. So all about the energy that provided by the waves are coming in. You know, the erosion processes are taking place here. So of course, what you end up with is with the softer rock eroding at a faster rate than the harder rock, or the less resistant rock being eroded, being worn away at a faster rate than the more resistant rock. So what we're ending up with here are our headlands. So headlands, pieces of rock that are sticking out into the sea, and our bays that are sheltered. Now what you can see, often an identifying feature of a bay is a beach within it. Deposition has taken place to leave a beach within the bay as the waves slow down as they enter the bay. Now we are going to look a little bit at deposition, and we have in the past looked at a thing called wave refraction, but we're not going to go into that now. We're really focusing on what's going to be in your exam in a couple of weeks' time that I want you all to achieve really well, and we're going to talk about how we're going to arrange that and how that's going to work. So you're jotting down your diagram now. You don't have to show all of it, you don't be exactly as it is here, but the key thing is you've got those bands of less resistant soft rock, more resistant harder rock, and how they erode at different rates. So the soft rock is eroded away to leave us with a bay. Hard rock is less eroded, leaving us with our headlands. So we're led with our headlands and bays. So this, in your exam, they could ask you about the feature formed on a discordant coastline, and you would maybe have to write about that. And you know, I have said to you, if there is ever a question where they ask you about formation, you draw a diagram. Whether they ask you to draw a diagram or not, you draw a diagram because it gets you the marks, and also it sorts your faults out. So when you're writing your answer as well, that's why you need to know this diagram. What I want to ask you about now, you'll see there's a sort of a small box underneath. So, and the question in there, what affects the rate of coastal erosion? So you've got the question now. I'm going to leave that on there just so those people who might still be jotting some things down. In the comments, could you put down for me, brief state, what different factors that we have discussed today, or maybe factors we haven't discussed today, would affect how quickly an area of coastline erodes. So why do some parts of the coastline erode quicker than others? Could you answer that in the comments for me? Excellent. I'm seeing, yeah, type of rock, the weather, yeah, so weathering could affect why the rocks break down. Prevailing wind, excellent. So the direction of the prevailing wind, is it coming, does it mean the waves have more energy? So yes, the fetch, rock type, wave type, certainly. Can you think of anything that humans do that would affect how quickly the coastline is eroded? Engineering, yes. What are your two types of engineering? So certainly, yes, building on the coastline, that adds weight to it. We've got hard and soft engineering, excellent, Emma. Yeah, building on the coastline adds weight to the cliff tops, which makes them more likely to collapse. So Barton-on-Sea is an excellent example of that, which some of you may have looked at when we looked at coasts. So we need to be answering this question now. What affects the rates of coastal erosion? So excellent, we need to mention how the fetch does. The length of the fetch affects whether the area is eroding quickly or slowly. We need to talk about the rock types. So referring back to what we did last week, a more resistant rock, an igneous rock, is going to erode a lot less quickly than a softer rock, a softer sedimentary rock. So you can mention that as part of your answer. Again, so you could link it into the type of wave that's affecting it. If constructive waves hit that coastline, then you're not going to get erosion. If they're destructive, you will. As Emma said about engineering, is there hard or is there soft engineering? We know, generally speaking, hard engineering is more effective. So if there's hard engineering, the erosion should pretty much stop. Soft engineering might just slow it down. Building on the coastline can affect the rates of erosion because obviously it's going to lead to the cliffs collapsing more often. You may well have seen in the news a few days ago the house that was getting eroded and then eventually fell into the sea. So, lovely sea views, and then they literally were in the sea as well. Very cheap house, though. As I've said to some of you before, you can buy a house for £1. Lovely 4-bedroom house next to the sea. The only problem is it's soon going to be in the sea. So, excellent. Answering that question, rates of coastal erosion. Next thing we need to go on to, and again, this is all things we need to know for that exam, is longshore drift. So, I'm actually, you need particularly this diagram here. So you need to be able to explain what longshore drift is and how it works. So you can write it, you could do it as bullet points if you want to in that space. So you could write it as a bullet points, or you could do it as a diagram. Now, obviously, a key thing that we have talked about in the past is if you're drawing a diagram, really there should be sequence on that diagram. So this happens first, this happens next, this happens. So ideally you would number the labels on your diagram, or you could number your list of what's happening. So we need to be putting in that space about what longshore drift is. So we can see on that diagram what we've got is the waves coming up the beach at an angle, and that angle is determined by the direction of the wind. So the coming up. So here we've got our waves coming up at the angle here, and we then have the swash carrying our pebble up the beach at the angle the wave is coming up the beach. We've then got the backwash. So as we've said before, the backwash comes down 90 degrees. Due to gravity, always comes directly back into the sea. Then the wave comes along again, picks up that pebble and takes it up the beach at the angle the wind is coming in, and then straight back down due to gravity. So you get this continual action of sediment moving along the coastline. You have got to, and I've said this to you before and I will say it again, you need to make sure that line comes straight back down into the sea. If you have it going down at an angle, you are not going to get the marks you need. So it must come up the beach at an angle that the wind is coming in, and down the beach directly due to gravity. So you need to be, say, doing your sentences or doing your diagram now. So wind picks up the pebble, takes it up the beach at an angle. Backwash brings the sediment straight back into the sea. And then you have that continual process. This, of course, is showing you the natural process of longshore drift. There is, of course, a type of hard engineering that interrupts this process. Could you put in the comments what is the process? What hard engineering technique disrupts longshore drift? Thank you, Liam, for spelling it right. Not the other type. That's something completely different. Thank you. Emma, get your mind out the gutter. Not that type of groin. Yes, groins. So wooden or rock groins. Wooden or rock groins sticking out into the sea. They would trap longshore drift to make the beach wider, so therefore erosion is less. Excellent, excellent, excellent. Thank you for all those fantastic answers. That's brilliant. So we've got that point. We're building up to our exam question and our exam that's coming up. So when we've got our longshore drift taking place, we are then going to be left with depositional features. Deposition creating things. So we've had our erosion. Beginning of the lesson, we started with erosion, hydraulic action, abrasion, attrition, solution. We then had our sediment being moved, saltation, suspension, traction. We're then getting longshore drift as part of that process, moving sediment along the coastline. So this then leads us to the last part on this page, which are the features created by longshore drift. So you just need to add these labels onto your picture. So, and one thing that people leave out and don't talk about is that in the writing I put there, why does deposition occur? Deposition occurs when there's not enough energy to carry the eroded material. The waves of lost energy, they don't have the energy to carry that material. So of course that bigger sediment tends to stop first. Traction tends to stop first. So if you could be adding these labels to your diagram, I think bar and spit, in reality, bar and spit are probably the two that you're going to need to know. A tombolo is really just a spit that joins a headland up to an island, and you won't need to look at cuspate forelands, but you know, we'll put it in there anyway, why not? But the two you need to focus on and we need to know about for your exam are bars and spits. That's what we need to know. You might want to say just on the space on the side, just that little point I've mentioned. Deposition occurs when there's not enough energy to carry the eroded material. That's why it's dropped. And again, that's another area that people lose out on marks for. They don't know, they know what deposition is, but they don't really know why it happens. So, you know, the water could get, the actual depth of the water becomes shallower, so there's more friction, so deposition occurs. It could be there's something blocking the wind, and as the wind is blocked, the energy of the waves decreases, so deposition occurs. And that's how you're going to be making your difference. So what we've got to do is take everything we've looked at to construct our 8-mark question. Because one thing I'm worried about is we've all got a little bit rusty on exam technique. And we have spent a lot of time talking about exam technique over the last year and just how important it is. If you don't get the structure right, if you don't answer the question in the way the exam would want, you're going to lose out on very easy marks. And we want to make sure we pick up every single mark we can. So could you have a look on your next sheet and you will see the exam question that we are going to be looking at today. First thing we're going to do is we're going to bug the question. We're going to go through and break it down. So we're going to box the command word. We're going to underline the keywords, and then we're going to make sure when we're answering the question that we're glancing back and making sure we're actually answering the question that is there. So let's start to break it down. So first of all, we need to say what the command word is. So it's an examine question. So I've given you a space. We need to say what that means. So in that space underneath the question, once you've highlighted or underlined examine, so examine, break something down into its individual processes and say how each one individually contributes. We have got to go step by step how something happens. We've got to show that. That's what examine means. It's step by step what's happening. So breaking something down into the individual processes. You only get examine questions in the section about coasts and the section about rivers. You don't get examine questions anywhere else in the exam. So it's always going to be the formation of something being made, step by step it being made. So the next key words we could underline, physical processes. We know the physical processes that we go on. I talked about them last week, repeated them today. You specifically name those processes. It's a formation question. So how is it made? So what physical processes, how do they work together to make a spit? And of course, as some of you know, I've mentioned this a few times, the key part in this question subtle clue must be shown in figure 2. You have got to use figure 2. If you don't use figure 2, you get 2 marks out of 8, and you could write all day long and you're getting 2 marks maximum. You have got to use the figure that is there. You must use the figure. So we've broken down the question, and I would expect you to do this in an exam where you would underline or highlight to break your question down. So let's start to have a look at how we could answer this question. We're going to look step by step how this spit has been formed. So you can see you've got a table underneath. So what we're going to do is we're going to divide the formation of this spit into 4 paragraphs. We know it's an 8-mark question. We always do 4 paragraphs. Slightly different to sort of format to what we look at with some of the other ones, because what we've got is that box for evidence. We've got to say how the spit is formed, and then we've got that we must give some evidence from figure 2. So it makes us use figure 2. The last one, the last box for box 4, we would always use for what's going to happen in the future. So a predictive thing that we could say is going to happen. So let's start to have a look, and we're going to break this down into different parts. I've given you a different diagram just that might help you to organize. So for that first paragraph, so in the bottom corner, we've got our diagram that's from the exam, and then there's just that other one there that might help us. So our first paragraph, I think we need to talk about the wind and the prevailing wind. So our first box, and again, when you can write it, you can just do bullet point marks or whatever into the explanation box for explanation 1. So we need to talk about the waves sort of moving along. So I think we need to talk about the wind direction and also the drift. So we could say how, well, what's our first piece of evidence that we could put into the evidence box about wind direction, making sure we use the figure that's here. So rather than just saying the wind brings the waves up the beach at an angle, using this figure, could you maybe mention in the comments, rather than just the wind brings the waves at the beach at an angle, what could you say about the direction of that wind that means you're using that figure? Southwest, excellent. So you could actually, because you've got a northing here, we know what direction the wind is coming from. So in your boxes now, in your evidence, you've got southwest. In your first box for explanation 1, you could say how the wind is coming, the wind direction is forcing the sand or the sediment up the beach. This is called swash, and then back down the beach, this is called backwash. So you could start to talk about that. So in your explanation 1, you could talk about what's actually happening. You've got the direction of the wind, you've got that longshore drift is taking place. So you could talk about what longshore drift is. So your explanation box is about prevailing winds. You could even mention fetch and what longshore drift is. That's what your explanation is. For your evidence, we've said, and some of you have brilliantly said on the comments about the direction of the prevailing wind as evidence. There is something you could say about the longshore drift. So again, using the evidence that you've got, what can we say about the longshore drift? Where is it going? What direction is it coming from and going to? If you could put that in the comments, because it gives us the movement of sediment. Which direction is it coming from and going to? Coming from the west to the east. Excellent, excellent. Put that down in your evidence. So again, that's evidence you could have only got from the diagram. You're the marks. Brilliant. You've used that company. Brilliant. Excellent. So our first paragraph is looking really good. So we've talked about the direction of the wind, we've talked about what longshore drift is, and we've actually got 2 lots of evidence of what's happening and linking it to figure 2. So let's go on to explanation 2. So we're getting to this point sort of here. So we could mention obviously how the spit is coming off of the headland. So in our explanation 2, we could say how the spit is formed off of the headland. You could mention what a headland is. You could demonstrate your geographical knowledge. So in your answer, you would say the spit is extended from a headland. A headland is an area of hard rock sticking out into the sea. So you could give that definition. Now, obviously, what you're then talking about is our spit extending. So we need, again, some evidence. We're saying that our spit is extending into the sea due to longshore drift. What could we use to tell us something about this spit? So thinking about, and again, you could put in the comments, look what else has been given to us on figure 2. What could we say about the spit? So yes, the size of it, you could talk about the length of the spit, approximately about 6 kilometers long. You could even say about how wide the spit is, so probably about 2 kilometers wide. So you've talked about how the spit has come off the headland. You've said what a headland is. You've demonstrated AO1 knowledge. You've demonstrated you know geography. You've talked about the spit extended into the sea, but then as your evidence, you have used how long the spit is and how wide the spit is. So about 6 kilometers long and about 2 kilometers wide. Excellent. Some of you are starting to talk about the recurved tip. So maybe we could move on to that when we get into explanation 3. We will talk about the recurved tip. So yes, we have got the recurved tip at the end of the spit. So for explanation 3, we could start to talk about the recurved tip. You need to obviously say why there's a recurved tip. Again, could you mention in the comments, why is there a recurved tip? Why is the end of the spit changing direction? Why is it not just, why is it change direction? Anyone put in the comments? Wind directions change. Excellent, Karen. So the wind direction changes. So when the wind direction changes, again, the usual direction is, but the wind changes direction and it causes a recurved tip. So in your explanation box, you're saying what a recurved tip is. For your evidence box, what could you say about the wind? Where is the wind coming from to cause the recurved tip? You can mention that in the comments, because that's going to be your evidence. Which direction is the wind coming from to create it? Excellent. Southeast, brilliant. So that's your evidence. So we've started to talk about the recurved tip. We've said what it is. It's when the wind changes direction temporarily. And our evidence is we've got actually saying it's come from the southwest. I think also in this part, in explanation 3, we need to talk about that salt marsh. So we need to say what a salt marsh is. So what creates a salt marsh? Thinking about our processes, what process creates a salt marsh? Again, if you could answer that in the comments, think about that. You are on fire today. Superb. Deposition. Deposition. So we know the salt marsh is formed by deposition. It's when the waves have less energy. Why might the waves have less energy at that point where the salt marsh is? What's stopping the waves having energy? What's getting in the way of the waves? Again, if you could put it in the comments. Superb, the spit. So we need to start talking in explanation 3, it's sheltered by the spit. Superb. So we need to say how there is a salt marsh formed behind the spit. Excellent. We need to say so the salt marsh is an area of deposition, and this has occurred because it is sheltered behind the spit. Again, we could use the scale to tell us something about the salt marsh. So you could use the scale to say how wide the salt marsh is. So you could say how the salt marsh is approximately 5 kilometers wide. So again, there's your evidence. There's your evidence that you have looked at. So you can see these questions, it really is sort of like, say what you see, you're saying what's in front of you. You're putting these things up. Now, final one is the explanation 4 is the future. And actually there's various things you could say here. So what could possibly happen in the future? Bit trickier. Excellent. Some of you have mentioned a bar. So a bar and a lagoon could form. What would have to change for a bar to form? Something's stopping it at the moment. Something is stopping the bar being formed at the moment. Where the wind is causing the recurve, they say the river. Excellent. If you notice, it says about the fastest flowing river. So you could say if the river slowed, the spit could extend, forming a bar and lagoon. So you could say that is one thing that could happen in the future. So you could say if the river slows, the spit could extend, forming a bar and lagoon. And again, you're demonstrating knowledge. Of course, what could happen if there's a big enough storm in the future, if there's a big enough storm and it, what we call breaches the spit, breaks the spit, what would happen to the salt marsh if there was a big storm that breached or broke the spit? What would happen to that salt marsh behind it? Yeah, it's going to get destroyed. It's going to get washed away because those waves are going to have more energy. So could you now, for explanation 4, could you now talk about that? Let's talk about the future. What could happen in the future to our spit? And again, you can refer to what's in front of you because, of course, you've got your fastest flow, etc. Superb. Okay, brilliant. And then just the final thing is some really good stuff today. Your home tasks. So the last activity on that sheet, you will see there is an exam question. What I would like you to do with that exam question is you can see you're going to go through the answer. I've given you the answer. You need to go through and color code this answer. So you're going to use one color for the types of coastal management, one color for the evaluation of that management, what was good and what was bad about that management, and one that is specific information about that place. So you'll need 3 colors, or you could use 3 letters and just write them onto the sheet. So that is your task for this week. So that is your task for this week. If you could send it over to me when you've done it, that will be fantastic. That is all for today. Trying to round up because I know you've got lots of other work to do from lots of other lessons as well. So the recording will be here, and of course the documents are on in the files area of this team. Thank you very much for your excellent work today. Some brilliant comments that came through as well. Really well done. So fantastic. I look forward to seeing you all soon and getting you those amazing grades you all deserve. So have a good rest of the week. Work hard, but not too hard. So I will see, well, some of you do some work. I will see you all soon. Cheerio. Bye-bye.
No, I don't. How?